I'm delighted to hand over to Andre, who I have made you a co-host. You should be able to share your screen. Is going to talk to us about the LCA of milk. Speaking about LCA in the ag sector, looking forward to this. Andre, over to you.
Okay, thanks, Emily. Hi, guys. Great to see you all. I probably don't know all of you, but it's good to see some familiar faces there. I'm Andre Mazzetto, as Emily. Thanks for the introduction, and thanks for the invitation as well, Emily, and the LCANZ. I joined AgResearch about 2 years ago, coming from the UK, but as you can see from my accent, I'm not British, I'm Brazilian. I was doing a postdoc there, and then since Brazil, doing a PhD, working on LCA, mainly on the pastoral sector, so beef and milk. So I joined AgResearch, work with my colleagues, which you probably know, Shelley Falconer Stewart Ledgard. And what we've been seeing over these 2 years is continuous engagement from the industry and a lot of interest on LCA. Well, we work mostly with the pastoral, so dairy, beef, sheep, wool sectors, and they are very keen on LCA. They mainly for marketing reasons, but also to understand and their emissions and how they can improve that. Fair to say that most of them are interested in the carbon footprint, not more on the other indicators. So today I'm going to tell about one report that we did recently, which was this mapping the carbon footprint of milk for dairy cows. That was commissioned by Darren Z. And I presented this because it had some very good traction on media. Some people, several comments from, including internationally. Some people got a bit angry with the ranking that they got on the countries. So that's something that came from that study. I think will be an overkill to explain to you guys what LCA is. So I will skip that part. I think you all are very aware of that, how an LCA is done. And of course, all the stages of a cradle to grave life cycle assessment. What I put there was the 4 main impact categories that people, well, the industries that we work are interested, basically climate change, the carbon footprint, water, land, and resource depletions, especially fossil fuel. So those are the main impact categories. So what an LCA of milk production would look like. So here you have the red boundary, the cradle to grave. So starting with our upstream data, moving to farm level, the both products of dairy farm, and then moving to processing, retail, consumer, and disposal. There are very few studies at the cradle to grave boundary and those studies, they show that most of the emissions, most of the impact, not just the greenhouse gases, are on that blue dashed boundary, the cradle to farm gate. So several studies there. If you compare, I think there are 5 cradle to grave, more than 100 cradle to farm gate. So if you zoom in inside that blue boundary, considering, for example, a New Zealand farm, a typical farm in New Zealand, what you see that is not just the dairy farm itself, but we also have, for example, during 2 months of the year, during the winter, especially in the South Island, farmers move their cows to a different farm for the wintering off process, and then they bring back the cows 2 months later when they are calving and when they are milking. At the same time, some farmers breed their own replacements on the farm. Other farmers buy the replacements from other farms. So you have to consider that as well. So sometimes when you use simple softwares, they lose this type of view of this life cycle thinking of a dairy farm, looking only at the farm itself, not as the replacements, the animals bought, the animals when moving from different farms, especially in the South Island. So what we've done on this report, that's an example that was published February this year, as I mentioned, commissioned by Darren Zed, and was a structured review of the literature based on life cycle assessments of milk production from different places in the world. And the idea of that was to have this a robust comparison of the, in this case, they were interested in the carbon footprint between different countries. So I think as most of you have this feeling when you are trying to compare LCAs, is very hard because people use different functional units, people use different allocations, people use different, in the case of carbon footprint, global warming potentials. So what we've done was to select studies, peer review, published in the scientific literature, focusing on the cradle to farm gate, which we know is the main one, and then we have more studies to compare as well. Studies that had a representative numbers of farms, and then also we went deeper on those studies and trying to recalculate all the main factors to standards. So standardizing everything to have a fair or a more fair comparison as possible. So how do we did that? First stage was searching for the result, for the papers. And as we say, we want to get a representative footprint of the country. And most studies on LCA of dairy farms, and also beef and sheep, they are done in 1 farm, 5 farms, 10 farms, most. And it's very hard to say that those farms are representative of the whole country. So what we do that was we selected you can say is a random number, 100 farms. But what we also look at was if the authors claim that those farms were representative of the country, or if there is a region that was analyzed that produced most of the milk of the country. So for example, there's a region in Italy, one study published with 38 farms, I think. And they and that region produced 80% of the milk in Italy. So we included that on because of the representativeness of the region in the country. Second stage was selecting studies based on the global warming potential. So as you know, the global warming potential changes every 6 years. And if you are following that, the IPCC just published a report a couple of months ago. So we now have the assessment report for the AR6 with different numbers for global warming potentials for the 3 different gases. Carbon dioxide is the standard, stays the same, but methane and nitrous oxide changes over the time based on best science available. So we selected AR4 and no special feelings about AR4 is just because most of the papers use that. So it's a factor, one less factor for us to recalculate. So when the paper didn't use, let's say they use AR5, we read the paper, checked data, so we could recalculate if there was data enough there for us to recalculate the footprint based on AR4 GWPs. If not, we contacted the authors and try to get most of the papers there. So as I mentioned, AR4 was the selected one. And here's an example of a paper that the only factor we had to recalculate was the GWP. As you can see, there's not much change at the end of the footprint on the GWP recalculation. The second one was, of course, function units. Several function units are used on different studies. The one that is recommended is kilograms of fat and protein corrected milk, or FPCM. And that's the one recommended because different breeds of animals produce different amounts of milk, and second, different milk with different contents of protein and fat. So that's a way to standardize them to the same level. So, and same idea as the DWP. We selected the papers that used FPCM. If not, we look for data for recalculating. If not, we try to get in touch with the authors to get data for this recalculation. And the last one, that's an example of paper in Denmark. The only one, the only change we have to do, a recalculation, was the functional units. And you can see there's not much difference as well on both GWP and functional units. What it has a big difference, and you may already guess which one is that, is allocation. So the dairy farm produces both milk and beef. So the calves that are not used for replacing the cows are usually sold for meat production. And we have to consider that when allocating emissions in a dairy farm. There's a range of allocation methods available. The one that is the most recommended is the biophysical, which is based basically on the production of the milk and the live weight of the animal when it's leaving the farm. So same idea of the other two. We selected the papers that use that one, tried to recalculate based on data, got in touch with authors. But this one, since was the most variable, we also applied 85% allocation to milk, which is the default recommended by IDF, which is the International Dairy Federation. So usually on a dairy farm, 85% of the burdens goes to milk, 15% to meat. Of course, we have more intensive farms, there's more allocation to milk, dual purpose farms, less allocation, but that's an average value that is recommended. And yes, very variable. So you see in some papers, the recalculation led to smaller footprints or lower footprints. And on others, it led to higher footprints. That's because of the different allocations being used there, or sometimes very similar ones as the one in the middle, the French study. So finally, that's our final flow diagram, if you wish, showing each of the stages that I just mentioned and how the studies were included or excluded of this review. And we started the review with 86 papers and 24 survived that flow diagram, which means we had at the end 24 papers in this study. A good geographical distribution, not many papers though, especially in South America and Africa, but we managed to get some papers in Asia as well, especially China and India. Most of the papers, well, some countries had more than others. New Zealand, Italy, and Ireland were the ones with 3 studies each. So, and that's the final result based considering all the recalculations. So there's several things to unpack in this image there. The first ones, if you look at the top, you see the developing countries, Peru, Costa Rica, Kenya, India, mainly with a footprint that is higher than 2 kilograms of CO2 equivalent per kilograms of fat and protein corrected milk. And if you look at the bottom, you'll see New Zealand, Uruguay, Portugal, and Denmark with a footprint of lower than 1. In the middle, there's a mix, but mostly developing countries that we found studies. The second thing you may look there is the different bars have different colors. The red bars were the studies that used the biophysical allocation, and we didn't need to recalculate the allocation. So there's a more direct comparison between the red bars. All the other blue bars were studies using economic allocation or energy or mass, and then we had to recalculate, sometimes with data, sometimes using the default IDF. And the third thing to notice there is that you see Australia, Portugal, and New Zealand with hash bars. That's because they are mainly using regional specific emission factors rather than the full emission factors from the IPCC. And that can influence the final result as well. There's a different way to visualize this data. So if you look at the vertical axis, you have the carbon footprint. At the horizontal, the milk production per cow. So one way to see that is plotting the countries there. And if you are looking for a regression line, there you go. But this doesn't tell much because there's something missing there, and also in the previous chart, which is the share of the greenhouse gases. If we're following, like I say a couple of weeks ago, IPCC published a new report focusing a lot on methane, especially giving a special emphasis on the methane. That's because there's a proposal for new metrics, making the differentiation between the carbon that is on the left side of the image, being extracted from fossil fuels and being burned, for example, in vehicles, and that carbon dioxide that will stay in the atmosphere for hundreds, if not thousands of years, different from the impact of the methane, which if you look at that CO2 in the middle of the cloud there, we all know that a process in photosynthesis where the grass will remove the CO2 from the atmosphere, the cow will eat the grass, transform that in meat and milk. But since the cow is not a very efficient producer of is not an efficient machine, let's say, it also has some inefficiencies, removing some carbon by the feces, or also the enteric fermentation, bleaching out that carbon in form of methane. So that methane will go to the atmosphere, will warm the atmosphere during 12 to 20 years. And after that, it will be degraded back to CO2. And that will go full circle, and the circle starts again. So the new metrics are taking into consideration this short circle of 20 years of methane when compared to 100 years or maybe thousands of years for CO2. So what we've done was look at that chart again and look at the profile, the emissions profile for each of the countries. And that's a mix of a scatter plot and a pie chart, which I like to call a scatter pie. Some things to unpack there, and I will go step by step. First, if you look at this corner, you see countries that have a large milk production and a footprint from 1 to 1.5. And they are mainly European countries and countries from North America, like United States and Canada. If you look at the distribution of the greenhouse gases, you see almost an even distribution between the three, sometimes a bit more, not much more than 50% to methane, the blue one. That's mainly because those countries, they have to house the animals, they have to keep animals indoors, they have to bring food, feed from sometimes other countries, and that has a footprint being considered on the upstream calculations, and also manage the manure management of that during the winter season. So that gives more emissions to CO2 and nitrous oxides. If we look at the opposite end, you see those developing countries which have a low to medium production of milk, but a higher footprint over 2. But you see the differences quite easy to see. Most of the emissions are related to methane, because those countries, they are on extensive pastures. Animals are grazing most of the year because of the climate that helps as well. And so emissions from the manure, they are deposited all in the pasture. They are very low, and there's not much feed being brought in for those animals. And of course, you have these guys in the middle. And if you just go on the ones that are lower to 1 or close to 1, which are Ireland, Australia, Uruguay, and New Zealand. Those are the usual suspects of having lower footprint for milk production. That's because those countries, they have the similar characteristics as those on the top left corner, with grazing management most of the year, or if not all the year, the animals are in the pasture, and most of the emissions goes to methane. You can see the effect of the winter though in Ireland, when you see that almost 50% is methane compared to the other three. They are basically pasture-based systems. So the conclusions of this study were that New Zealand showed the lowest carbon footprint, and that was something that the industry was first very happy to see. Second, they use it a lot, and they keep using that every time they have to make justifications about greenhouse gases emissions. Second is the allocation is the key factor on the dairy farms. We've seen some effects when we recalculated the GWP and the functional units, but not much, mainly the allocation. And the third one is these different countries, they have different greenhouse gas profiles. So when considering these new metrics, that will have can have a different impact on the calculations of total emissions as well. So that was one example of what we have been doing recently. And other ones that, just to mention, we are currently working with MPI for calculating a cradle-to-grave footprint of the milk production. So considering all the stages of the life cycle of UHT and milk powder exported to China. And we are also, based on the literature, calculating a carbon footprint for the Chinese milk produced in China to have a fair comparison, again, of the New Zealand product with overseas product. What we've done over these last years was as well the simple milk. If you know the Fonterra milk, the carbon zero, that calculations were done by AgResearch, and Toitu made the certification of that, and now it's being sold in the markets as a carbon zero or net zero milk. Same for the Silverfern Farms Angus beef. That's a net zero that is being sold now, they are selling now to the United States. So both of these projects, the Simple Milk and the Silverfern Farms, we worked together with Toitu. We did most of the calculations, they did the certification. And we just finished a report of beef and lamb for Beef and Lamb New Zealand for beef and sheep meats produced here in New Zealand, exported to different markets, a cradle-to-grave footprint. And that should be available as well soon, as well as the report for MPI. As I mentioned, there's a lot of interest on the industry. We've been consulting with dairy, beef, sheep, wool, pork fisheries. Many people interested in LCAs, many people wanting to have these calculations done. As I said, especially for carbon footprint, but we are also pushing for looking at other impact categories, mainly land use, resource depletions, and eutrophication, which are relevant for the pastoral sector in New Zealand. So happy to take any questions, and thanks for your time. Thanks for the opportunity to talk with you. And if you want to get in touch as well via email, you have it there. Thanks, Emily.
Andre, thank you. That was fascinating. Before I throw the floor open, I'm going to take precedence right and have some first reactions. I think the really interesting your points about allocation and functional unit and the importance of those being the same in order to compare. It's obviously as LCA professionals, we know this, we know how important it is, but it's really great to see that brought to life and be able to show it. And a scatter pie is going to become my new favorite. That was an amazing way to show the data and really interesting to drill into it and to understand it. And yeah, exciting to see the work that's coming up as well. And perhaps John might get to see an EPD for beef and lamb if the LCA is so far developed. So thank you, and throw the floor open. If perhaps if you'd like to, let's start with if you'd like to unmute yourself. If we have too many people talking at once, then we'll start going through a raised hands process. But let's start by trying to just keep it open. Anyone like to jump in? John.
Thank you, Andre. And that is a fascinating study. I have read the paper, but I enjoyed the walk through that you did, and I'm pleased about that. I'm interested in the short cycle with grass, and of course, I've often been asked, what about the fact that I'm growing a lawn, and how much carbon is going into a lawn, which isn't terribly serious when you mow it and stick it in the compost. But that is an interesting concept. Is that getting much international traction? Is that I understand our interest in it in New Zealand, but is it internationally happy?
Yes, that's getting a lot of, well, thanks for the question, John. The recent IPCC publication, they focus a lot on methane, and there are different metrics for being used. So we know the GWP 100, that those are the AR5 values. And what they do are showing how much over 100 years that those gases are, how much pressure they are putting in the atmosphere, let's say. What's the impact? What this new metric there is proposing, the GWP star, they are calling GWP star, basically is saying if the methane over the time is keeping the same level, so if you're keeping the same amount of methane over 20 years, your effect is not cumulative. It's different from carbon dioxide. So if you emit carbon dioxide today, and if you emit carbon dioxide in 20 years, you are accumulating carbon dioxide in the atmosphere over the time. Even if you're emitting the same amount, it's being accumulated. If you're emitting methane because of that cycle, if you're emitting an amount of methane today and you are emitting the same amount in 20 years, that methane from 20 years ago disappears, and this methane now is replacing. So you keep the same level of pressure in the atmosphere. That's what this new metric are trying to show. So if you have more emissions, of course, you are accumulating, and that the metric shows that as well. If not, if you are even keeping constant or reducing, the metric acknowledges the emission with a negative. So, for example, the sheep sector in New Zealand. 20 years ago, we had high number of sheep emitting a high number, a lot of methane. Today, we have 30% less sheep. So let's say a direct comparison, 30% less methane. So if you calculate the methane emission with this new metric, you get a negative value, showing that methane is putting less pressure in the atmosphere today compared with 30 years ago. And if you think about that, may seem like a good scenario for the industry, saying, okay, try to get out of the jail-free card, because, we're not putting too much methane anymore, so we're not the ones to blame. But since methane has this short cycle, the target, if we need a very quick answer to climate change, and we do need a quick answer to climate change, the target should be methane. We should be reducing all the greenhouse gases, but the target should be methane as well. So it is good and bad for the industry.
Something of a conundrum.
Yep.
And I'll ask one other question, which I'm sure you've got a hint of from my EPDs, and that is that you're doing a lot of agricultural and food-based LCA, but we don't see it unless we come across either an MPI report deep in the website. People are very interested in their personal footprints, and And when I first, my business first put out a do your own household carbon footprint, somebody said, what about food? And the only figures that I could get were from an American website.
Yes.
And of course they're wrong, because New Zealand is so good. But we need to get a little more publicity about the technical data of our agricultural emissions out into the public place, if you don't mind me saying so.
Yeah, most of the work that we've been doing, it's going to be public available because people want to, like for example, Beef and Lamb or the MPI or AgResearch want people to see that. But yeah, no, I can, and we have some of the projects, they are confidential as well. And then people decide whether they want to or not to share. An interesting one about food, and we've been discussing that here a lot, is that when you look at the carbon footprint, let's say, of 1 kilogram of soybean compared with 1 kilogram of beef, yes, 1 kilogram of soybean has a much lower footprint per kilogram of food. But if we are all practitioners of life cycle assessment, we know that the functional unit, right? And you eat food because, well, why we eat food? We eat food because of the nutrients we get from the food. And the nutrient profile of soybean is quite different from beef. So should we be comparing soybean and beef in kilograms of food, or by protein, by this essential amino acids, by iron or others? So that's something that we've been discussing a lot as well.
Another conundrum.
Yep.
May I pick up on the GWP star comments, please?
Sure, Lindsay.
That was really great. I was going to ask you a question, but you answered most of it. But one comment I guess I'd make is that one of the arguments in the ag sector that I've encountered for holding things the same, as you explained it, what's decaying at one end is being added at another, but is that we're working on a currently inflated level of methane because of dairy growth, aren't we? So that's the factor that's often not mentioned in that discussion.
Yes.
However, sorry, carry on.
No, yeah, no, you're absolutely correct. The GWP star shows if the level of methane is increasing, keeping the same, or decreasing. But it's not. It's like the people like the analogies with bathtubs. It shows the level of the bathtub. It not shows how much water is inside the bathtub.
Yeah, exactly. However, the real question I wanted to ask you was whether you factored soil carbon into your computations at all. And without going into too much detail, if you could give a broad sense of how you did that, if so.
No, because that's not, if you look at the ISO and the recommendations, that's the carbon sequestration is not included there. There's something in New Zealand. Well, there's two different, right? One is the carbon sequestration from soil, which one you mentioned, and the studies that we know in New Zealand, that New Zealand is very rich in carbon in the soil, and is different when compared, for example, from the United States, where you had crops that are being converted to pasture, and then now you're accumulating carbon in the soil, and then you are sequestrating carbon. Here we already have a good value, even better maybe than in other places. The second one that could be in New Zealand would be a zero, considered as a zero, the carbon from soil. What could be considered, but is more common in beef and sheep farms, is the carbon from the trees, the carbon being sequestered by the trees. And that, again, the recommendation is not to include. What we did in that report that I mentioned that will be released, we included, but separate. So as is recommended for any sensitivity analysis. So we calculated following all the protocols, and we included the carbon sequestration from the trees as a separate analysis, as a sensitivity analysis.
Thank you so much. Great answer.
Just working on your comment about the trees, does that relate to the trees that are being cut down in order to make the beef or sheep farm?
Yes, that's something that there was a report last year, Stuart. There was from I think Auckland University of Technology that they quantified the amount of carbon being sequestered by beef and sheep farms, by the trees in beef and sheep farms, but they didn't consider the emissions from, for example, harvesting or replanting, this kind of other activities. So the Ministry for the Environment recently this year published a report estimating, using those figures, but estimating these emissions as well. So you have a net sequestration there, considering the carbon sequestration plus the emissions from harvesting or the removal of the trees. So that's what we used in this study.
Okay, thanks.
Andre, could you just comment on the relative magnitude that you calculated for that?
That's another one that is a tricky one. Should be included, and we reported separately again, is the land use change. So you have what happened in New Zealand over the 20 years, and that's the time limit. There was changing from forestry to dairy in the land use, and the emissions arising from this change should be considered as well on the footprint. So when we add that, it adds 0.14. So the New Zealand carbon footprint goes to 0.91. What happens there is, as the GWP star is a temporary measurement. So if that was valid for 20 years, and when these 20 years they are gone, that those emissions are not more related to the carbon footprint, unless they keep changing forests to dairy farm, which I think is not happening since 3 or 4, maybe 5 years ago. I'm not very updated on this one, but that, yes, you're correct, Sarah. It should be included as well, and we reported that as a separate one. Mm-hmm.
You looked at all your other studies for the other countries. Did any of them include land use change?
And that was one of the things that only one study in Ireland mentioned land use change, and none of the others mentioned that. So it was kind of, and I don't know, I think that's a bit unlikely that only New Zealand has been expanding the dairy sector over the last 20 years. So that was one of the reasons that we didn't include on that figure, but we did report that it is included on the final report.
One follow-up question on GWP star, please, Andre.
Mm-hmm.
How are we getting on if we assess our emissions on GWP star,
mm-hmm.
and the international standard is GWP 100?
Yep.
How did we get on reconciling those?
Yeah, that's a good one. What the New Zealand government done, and the Climate Change Commission did the same as well, is that we have different targets for different greenhouse gases. So we are not accumulating, we are not calculating the CO2 equivalent. We have different targets. So that was one of the arguments that I was talking with one of the Climate Change Commission, one of the people that work there. And they said, no, we don't need to care too much about GWP 100 versus GWP star. We have different targets for different gases. I think that what's going to happen. I'm part of a FAO tag group on methane. We are discussing that the recommendations for LCAs, for example, is that we keep using the GWP 100, which is the standard one recommended by the IPCC and by the ISO. And we report GWP star to check if over the last 20 years, methane emissions are going up or down, but not the standard should still be the GWP 100.
Thank you very much.
I may have missed it. It might have been the comment that Sarah made while I was typing that message.
Mm-hmm. Okay.
But did you kind of talk about the differences in country-specific emissions factors? Because I know New Zealand puts a lot of work in making sure our emissions factors are really accurate, which may also be a reason why our results come out looking so good. So just needing to take some care around that when talking about ourselves compared to other countries. Given I'm the international policy area.
No, that's a good point. And there was a lot of contentious. That's one of the things that this report got a lot of attention, not just from media but from other people. This kind of stuff, the land use change and the discussion if should be included, not should be included. Why other countries are not including it, and also the region-specific emission factors, which you are correct. New Zealand has invested a lot of research money on, especially we have at AgResearch, Manaki Whenua, and the universities, a lot of studies on nitrogen fertilizer on pasture, urine on pasture, feces on pasture. And we use the inventory, the New Zealand inventory uses specific emission factors for those and for the methane from the animals as well. So yeah, when you look at the full IPCC, it got better. There was an update in 2019. So there's more, before was very generic until 2006. This 2019, you have a breakdown by climate, you have a breakdown by some of them by region of the world, by this type of meta-analysis or reviews that people did. But you are correct, it does make a difference. And yeah, and when we did that, we add that to the report. The only problem is that's the type of thing that is impossible to recalculate. It is possible, but you have to do the work again, all the work again, basically. So that's the kind of thing that is buried under the models. And then you have to dig real deeper and talk with people about it.
I guess you might find that other countries are keen to put out their specific studies with their really accurate data. So you might have got the ball rolling.
We're seeing, for example, Ireland, they are working a lot, and they calculated their footprint using, because for you to use specific region-specific emission factors is not like one study. You have to have several studies, and that has to go to the inventory of the country. So what, for example, Ireland did, they have a few studies on nitrous oxide from fertilizers. They include that in their calculation and show that it would reduce their footprint a bit. So yeah, people are doing that as well. Yep.
Oh, thank you.
Andre, yes, they're here.
How they?
Hey, hi. I had a different question. You mentioned that IPCC put a different sort of focus on methane this year in their study, and the reason for that, I mean, I'm assuming, I haven't gone through the report. I just want to know, is it mainly agricultural emissions or also emissions releasing from permafrost and accidental release from so, and do you have any is there any breakup you have in terms of percentage, what is contributing where?
I think that's on the report. I don't have on the top of my head now. I don't remember the percentage, but that's on the report. And yes, it's not just the agricultural. You are correct. There's the fracking, the methane from permafrost, all of those different sources of methane as well.
All right. Okay. Well, it looks like I need to go through the report.
Yes, sorry.
No, that's fine. I need to go through the report myself. No, that's all. Thank you.
No worries.
So some of those sources of methane might be more important than dairy cattle, for example. I understand that certain things like permafrost release of methane is increasing very rapidly, probably more so than cattle, I would think.
Yeah, as I mentioned, so I don't remember the breakdown now, but you can find that on the report, definitely.
There's been a lot in the news recently about fugitive methane from gas fields as well.
LCANZ,
yeah, higher than anybody had previously thought. So
precisely.
Scary stuff. And Andre, thank you ever so much. That was fascinating. Thank you for dealing with all of our questions as well.
No worries. Thanks for the questions. No,
very
thanks a lot.
Yeah, great to hear about something that isn't building products. Sorry to all of our building products members, but it's always good to spread the field. So thank you. It's been really interesting.
Thanks, guys. Thank you.